Today we're going to be completing the square. And completing the square is another way to solve a quadratic function. So completing the square is how we derive our quadratic formula. So I'm going to go through, actually I'm not going to go through this example, I'll do another one. But the first thing that I want to do is I want to move my constant term to the right side, so that x squared and x are on the left side, constant term is on the right side. Then I want to divide the coefficient of x by 2 and then square that number. Add that number to both sides, and if it's a fraction, I want to leave it as a fraction. Third thing that I do is factor the left side. It'll always be a binomial squared. And then I'll add my constant terms on the right side. Last thing is I square root both sides, and then separate it into two problems and solve for x. So, with this first one, first thing I want to do is add my 35 to the other side. So you get x squared plus 2x is equal to 35. Then what I'm going to do is, again, my coefficient for my x to the first power is 2. So I leave these guys here, but then I divide 2 by 2, which is 1, and then I'm going to have 1 squared, and that's going to be added to the left side. Since I do it to the left side, I also have to do it to the right side. On the left side, I want to leave it as 1 squared. On the right-hand side, I can actually do 1 squared, which is also 1. Once I do this, I'll have a binomial that is squared, and that's going to be equal to 36. My first term is always going to be x, and then my second term is always going to be whatever my number is squared, so it's going to be 1. So whichever number I'm squaring, if it was 5 squared, I would put a 5 in for my second term of my binomial. Once I'm here, then I can take the square root of both sides. So I get x plus 1 is equal to plus or minus 6. Again, I'm solving for x, so I have to include the positive and the negative situation. Then I'm going to separate this into two problems. X plus 1 is equal to 6. X plus 1 is equal to negative 6. Minus 1 both sides of these. So you get x is equal to 5, or x is equal to negative 7. And those are my two solutions. I don't have to check for extraneous solutions because I'll always have two solutions that work here. With the second one, again, I'm going to move my 3 over to the other side. So you get x squared minus x equals 3. Again, I keep this on the left-hand side. My coefficient for x is negative 1, and so what I'm going to do is I'm going to add to both sides negative 1/2, divided by 2, negative 1/2 squared is equal to 3, and then if I actually did the calculation, negative 1/2 squared gives me positive 1/4. So again, I have a binomial that's squared on this side, and on the other side, I have 3 plus 1/4, which is 3 and 1/4, and I want to put that as an improper fraction rather than a mixed number, and so that gives me 13 over 4. So when I factor this, again, my first term is always x, always a plus sign in between. My second term is always what I'm squaring, so it'll be negative 1/2. Take the square root of both sides, so I get x plus negative 1/2 is equal to, when I take the square root of a fraction, I can take the square root of the top and the bottom. So square root of 13 is on the top, square root of 4 is 2, so I can just write it as 2 on the bottom. I always have to remember my plus or minus. Then split it up into two different problems. X plus negative 1/2 is equal to square root of 13 over 2, and x plus negative 1/2 is equal to negative square root of 13 over 2. Solve both these by adding 1/2 to the other side. So I get x is equal to, they have a common denominator, so I can actually add them together, or I can leave them separate. So 1/2 plus square root of 13 over 2. And x is equal to 1/2 plus negative square root of 13 over 2. Those are my two solutions. Always have two solutions here. And there's the homework.